Welcome to our training webinar on Modbus-based data acquisition and data logging. Today, we will be introducing what Modbus is, how it works, the difference between Modbus RTU and Modbus TCP, how different kinds of Modbus equipment works, and we'll be going over the different kinds of Modbus registers. I will go over application examples that are using Modbus data acquisition equipment, and we'll be going over data logging, which is the process of collection and storage of data over time. It's used to track events, troubleshoot problems with systems, and to detect trends over time. It allows you to collect data like temperature, pressure, tank level, kilowatt hours, and on and off status. If you have any questions, please enter them into the chat box and we'll be answering them at the end of the training. I'm Maria Santella, sales manager here, and have been an application engineer in the past. I'll have Robert Murao, one of our senior application engineers, here with me, and he'll be given a demonstration and training later on, and we'll be showing Modbus-based data acquisition and data logging with Easy Data Logger. ICP DAS USA, industrial control products and data acquisition system solutions that are low DC voltage, can operate in extreme temperatures. ICP DAS, established in 1993, provides innovative industrial automation technology, ROHS compliant lead-free equipment, and is ISO 9001 certified. We have a knowledgeable team. Many members have worked for the company over 10 or 20 years, and we provide free consultation and can specify products for your applications, provide free technical support, and can help you with questions, setting up equipment, and troubleshooting issues. Our products are very reliable and come with a 1-year warranty. If you're going to be buying a lot of products in bulk and you need some configurations done on them before we ship, we also provide that service. We carry a large inventory and can ship the same day you place an order. We usually ship within about a week when items run out of inventory. We have training webinars every month on the latest industrial automation technology and have a vast library of training videos and other tutorials up on our website. We provide free Easy Data Logger software for data logging, control, and monitoring that works with most of our data acquisition equipment and can work with other vendors' Modbus devices as long as you have one of our Modbus devices in the network. Data acquisition, it's the process of sampling real-world physical information and the conversion of those samples into digital numeric values that computers and controllers can understand. The information is often used to implement control logic operations like the turning on of a fan based on the temperature, the turning on of a pump based on a tank level, and the opening of a valve based on pressure levels. Data acquisition information can be collected by a computer running control and monitoring software like Indusoft SCADA software or free Easy Data Logger, and data can be logged or displayed on a touchscreen computer. You can turn equipment on or off with the push of a button. Analog information is variable or adjustable in measurement like temperature, pressure, and flow rate. Digital information is fixed and is either on or off. A light and a light switch is an example of something that can be either on or off. A dimmable light is variable in intensity and is analog. Data acquisition modules read values, store them in memory, put the values in a register table, and sends data from the registers when requested by PLCs, controllers, or software. The ET-7026 communicates over Modbus TCP over Ethernet cabling, which communicates up to 100 meters and can be extended with an Ethernet switch like our NS205. ET-7026 has a terminal block that can be connected to sensors for collecting analog input information like flow rate, temperature, pressure, and carbon dioxide. The information is stored in registers that can be queried by controllers or software running on a computer. Information can be showed on a screen displaying the information, and measurements can be logged in a database or CSV file with a time and date stamp. We have a wide range of industrial data acquisition equipment, including remote and rack-based solutions in many types, including voltage, current, thermistor, thermocouple, RTD, strain gauge, digital, relay output, and accelerometers. Our data acquisition products are available in many protocols and interfaces, including Modbus RTU, Modbus TCP, Ethernet IP, EtherCAT, USB, RS-485, Profibus, CAN Open, DeviceNet, Wi-Fi, Zigbee, and more. Modbus is a simple and standard, robust serial-based communications protocol that's widely used for industrial communications for instrumentation, control, and data acquisition. It was originally published by DCON in 1979, so it's a very stable protocol. Modbus RTU allows for communication between up to 255 devices in one network. It supports communication distances up to 4,000 feet, which can be extended with a repeater like our I-7510. Modbus applications are easy to deploy and maintain. The devices in the network are daisy-chained together with two insulated copper wires. Each Modbus device in a network is given a unique address, and only the node assigned as the master may initiate commands. Ethernet-based Modbus TCP networks use stateless connections, and it's possible for two or more masters to write to the same register or coil in a Modbus device. A Modbus command contains the unique Modbus address of the destination device, and only the destination device will act on the command, even though the command gets broadcasted out to all devices on the network. Modbus commands contain checking information that ensures commands arrive intact. Commands can instruct a Modbus device to change a value in one of its registers, to read an I/O channel, or to send back one or more values contained in its registers. Our M7000 series communicate over Modbus RTU, and our ET7000 series communicate over Modbus TCP. Our M7017 Modbus RTU based analog input module is widely used in data acquisition systems in the energy industry. They're being used to get voltage information from our DN843I-CT-1 current input board, which is getting amperage information from energy being produced by solar panels. The voltage information is passed back to the WP5141 XW107 WinPack controller running a Microsoft Windows CE operating system. We provide free eLogger data logging software that runs in the controller. It shows the information on a screen that is accessible over a web page and also logs the data every minute. M7017 analog input modules are set up with DCON utility, which is used to set the unique address, the input types, and other information like baud rate and checksum. Our I-7561 RS-232, 422, 485 to USB converter is used for communication between the M7017 Modbus data acquisition module and the computer over the USB port. Modbus TCP communicates over Ethernet networks, and Modbus RTU communicates over serial networks. These two networks are not the same. You could use a Modbus RTU to Modbus TCP converter like our TGW715 to integrate network communication. You can also use an RS-485 to Ethernet converter like our TDS715 if your computer doesn't have a serial COM port. Our PoE, Power over Ethernet PET7000 series, allows for getting data and power through an Ethernet cable, making installation quick and easy. The PET7000 series communicate over Modbus TCP and are configured over a password-protected web page, which allows for configuration, I/O monitoring, and control. In the picture at the bottom, you can see they support standard type Ethernet cabling for using the Power over Ethernet feature and can be daisy-chained over Ethernet when each of them is powered with a power supply. Our Power over Ethernet PET7000 series are widely used in data centers and applications where installation of remote I/O modules is convenient. using Ethernet cables and power over Ethernet switches instead of many power supplies. They're also being used in tank monitoring systems. They get the tank level, pH, and temperature back to our WinPack controller, which runs a program and instructs the pump and motor to turn on for specific amounts of time based on measurement conditions. Zigbee wireless I/O modules communicate over Modbus RTU. They need a host converter so they can communicate back to a PC or controller. They're set up with some dip switches on the side of the product so they can be in the same wireless network and have a unique address. Zigbee wireless devices are ideal for applications where wiring is inconvenient. They're used in applications like factory automation and machine automation. Each Zigbee network has one RF channel and one PAN ID. Each node has a unique node ID, and it supports many flexible topologies like cluster, where nodes are arranged around the host converter in little bunches, mesh, where the host coordinator is at one end, or a star, where the host coordinator is in the middle. We provide Zigbee Alliance-based products that work with other vendors' Zigbee Alliance-based products. At the bottom right of this image here, you can see a host converter is connected to a PC. Each Zigbee network needs a host converter to act as the coordinator for the network. It helps establish the communication path between computers and end devices. The PC holds a monitoring and control program so operators can see the status of the factory, and they also can turn things on in their office as necessary through that program. To the left of the host converter, you can see a Zigbee I/O module, which is also used to turn things on or off based on conditions. The logic operations are all in that control program on the computer. At the top right, you can see a Zigbee slave converter attached to a touchscreen HMI human-machine interface, and with it, users are inputting the number of wood blocks that they cut with a saw. Other I/O modules and devices are connected to the wireless network for providing information for control and monitoring. If you need to send out alarms based on data acquisition information like tank levels, temperature levels, digital output signals, or energy measurements, you can send email alarms out to a designated list of email addresses or text messages out to different phone numbers. You can also use a SCADA app on your phone to get notified. Our WISE data acquisition modules and data loggers can send email alarms out, and they're set up through a web page. The WISE 7000 data acquisition modules communicate over Modbus TCP over Ethernet networks and have terminal blocks on board that you connect to sensors and equipment. Easy Data Logger can send out SMS alarms based on conditions and supports VB-script, so you can do calculations and arithmetic on your measurement levels and send out alarms based on the calculations. Our Aviva SCADA software comes with a mobile phone app that can be set up to send you notifications. You can see your SCADA system status and data logging information through the app and the status of your equipment. The WISE 5800 series collects data from Modbus RTU devices. We have a WISE 5800-M TCP that collects data from Modbus TCP devices. And these can be used to send out email alarms. They can also be used to trigger output based on inputs. And they store the data in a CSV file. And that CSV file can be emailed out to designated email address based on a schedule. And it can also be accessible through FTP. Easy Data Logger comes with a lot of different objects that you can put on the screen, like gauges, bar graphs, and tank level indicators. There's also numerical display objects and counters. There's also buttons that can be green when on and red when off. So you can easily see the status of your system all on one screen. It supports Modbus RTU and Modbus TCP protocols. DCON, it also supports that, and that's a proprietary protocol developed by ICP-DAS. It also supports the alarm notifications I just mentioned, and you can see a trend graph on the screen to see the status of your system, of your data logging system, and a spike can indicate a leak in a tank or when a piece of machinery needs to be repaired or replaced. Easy Data Logger is a Windows-based program, so it works on Windows systems, and you can use them with Modbus RTU devices. If you have one of our ICP DAS Modbus devices in the network, it also works with other vendors' Modbus devices. The free version supports up to 64 IO tags. We offer an advanced version that supports up to 1024. The free version supports one web camera, which is helpful for being able to see the status of your equipment, especially for remote monitoring systems. And the advanced version supports up to 10 web cameras. Now we're going to be, pretty soon we're going to be passing it over to Robert, who's going to be showing you a tutorial on our Modbus data acquisition modules. He's going to be showing you the Easy Data Logger setup and installation of Modbus devices into the data logging system. He's also going to show you the HMI interface and showing the status of your equipment, discussing Modbus registers, Modbus data acquisition, and Modbus data logging. If you have any questions, please enter them into the chat box, and we're going to be addressing those at the end of the training.
Okay, Maria, I'll transfer to my screen now. Let's see. Yes, I want to continue. Okay, share the screen. Okay, it should be popping up any second now. Okay, let's go to my slideshow. Okay, so let's see, just as an introduction, Maria briefly went over this, but I just want to go in detail. Easy Data Logger is our free easy data logging software, as long as you have at least one of our data acquisition modules, traditionally our M7000, I7000, or ET7000 series. The basic edition, which is the free version, requires at least one of our Modbus or one of our data acquisition modules, rather, to be connected at all times to be free. Then you can use other Modbus RTU or TCP devices along with it, up to 64 tags. This is the free basic version. If you have more tags and need more channels, you can also purchase the professional or advanced version, which has these limitations. Note that the virtual channels are used for mathematical operations or logic operations, like say an and or condition, like if you had two switches and you wanted to know an or condition, whether each of or if each of the switches or one of the switches was on, then you can use the virtual channels for that. Control logic can be used to trigger an output based on input conditions, based on counts, or based on a time. The web camera is pretty straightforward. You can show the operation through a web camera view. And the alarm contacts for the SMS or email operation, those are alarm or tied to alarm outputs, which are either triggered by the control logic or by alarm values. And let's see, for the time limit, as long as you register either the basic or professional, there's no time limit. If you do get the 2-hour limitation when you first sign up, or before when you first install, rather, be sure to sign up for the license to eliminate that 2-hour notification. So again, there's no time limit, not the 2-hour limitation if you register. So be sure to register the product. Okay, next slide. Okay, for this example, I will use one of our M-7026 data acquisition modules. This module has 6 analog inputs, which can be current or voltage, 2 analog outputs, 3 digital inputs with counters, and 3 digital outputs. Let's see, I'll show you the configuration. This is the configuration I have. There's a 24-volt power supply powering the M7026, along with RS-485 communication from our TM7561 connecting by USB to my computer. So since these data acquisition modules communicate RS-485, and most computers don't have RS-485 ports, you can use our USB to RS-485 converter, or we have other converters like Ethernet to RS-485 or RS-232 to 485 converters as well. The beautiful thing about RS-485 is you can daisy chain additional modules. So in other words, if you had, say, 3 M-7026 modules, you need to power each module, but you just connect the RS-485 wires in daisy chain format to two others, and you need to be sure to specify that each module on that bus has the same baud rate and parity options and different node IDs. And I'll show you a screen capture of that afterwards. But basically, Easy Data Log will run on my PC. PC is connected by USB to the RS-485 converter, which would connect to the M-7026 in this example, which is a Modbus RTU slave device with various I/O channels. And we're powering with 24 volts DC. Okay, the M-7026 module is configured using our DCON utility. So again, our modules, our serial modules are configured using our DCON utility, which is a free software. You do need to specify the COM port and be sure you have the right type of COM port to communicate to your device. Once you do that, you simply scan for the device and it'll show up like this, where M-7026 is the module shown here that was found. Its current address is 1, which is both in hex and decimal. Let's see, 9600 is a baud rate currently set, checksum disabled, format N81, and it's remote IO module with these channel configurations. I'll show you a live example in a few minutes, but just want to go over the steps for now. Okay, once you connect with DCON utility and you double click on the found module, you can get to the configuration page. For our data logging example later, we need to know the following information. We need to verify the module is in Modbus RTU mode. Each module has to have its own unique address. By default, it's 1, so we'll just use 1 since we are only connected to one module today. But if you do have additional modules or slave devices, each device must have its own unique Modbus slave address, and the baud rate and parity option of all devices on the bus must match. And for this example, we're going to use engineering data format. So let's see, so we can read the numerical values between, in this case, 0 to 10 volts, which would be 0 to 10,000. I'll show you that in a minute. And let's see, this is just an example using the AI and AO tabs to verify the values and the ranges for each channel. So currently I have 0, 1, 2, 3, 6 channels here. All of them are set for 0 to 10 volts. Only the first one's really connected. And for this example, I connected the analog output value to the analog input channel. I'll show you that. Well, actually, I showed you that previously. Let me go back to that slide. So again, that's what this wire is here for, just so that you can see both the analog input and analog output value. And currently had it set for 3 volts output, which corresponds to negative 2.99 volts. Oh, actually, I did find that in my previous slide, I, one more, had the yellow connected there, so that's why it was negative. I have since switched it so that they are both positive now. Wait, let's see it back here. Okay, so again, that's why that currently you see 3,000 here, which is equal to 3 volts, and you see negative 3 here, but it's since been corrected, so it's now 3 volts and 3 volts. Okay, these are just used for verifying that your wiring is correct from your input device, and you can see the correct value in the corresponding AI, AO, DI, and DO channels. If you did not have the right wiring, you would see the wrong voltage here, so you need to correct that before even attempting to connect to either your Modbus master or Easy Data Logger or any other connection you have. Okay, now we'll do a live configuration. First of all, I want to show you our DCON utility. This is our DCON utility. It's used to configure our data acquisition modules and check the channels and verify your inputs are wired correctly. So the process is you select your COM port using this icon. I currently have it connected to COM10. The module itself is set for 9600 baud, so I have that box checked. If I was unsure or possibly wanted to set it for something else, I can check those boxes as well. These are just search boxes, or I'm sorry, boxes to filter out what baud rates to search for. So it'll take twice as long if I have two baud rates selected, but since I know it's 9600, I'll just check this box. Protocol in this module is Modbus RTU. If we did have DCON or Modbus ASCII modules, I would have to check those boxes. And the checksum format by default is disabled, and the format is N81 by default. But if I needed to change it for my PLC network or for some other reason, I could also change that. But once you configure those for the search, you press this button to start a search, and it should find it. It just goes sequentially through. And the M-7026 was found here. The address is, again, address 1, 9600 baud, checksum disabled, and then we double click here to bring up that screen that I showed you previously. It actually appeared over here, but let me drag it over. Okay, so this is the module details currently. So the configuration, Modbus RTU, address 1, 9600 baud, N81. Checksum is disabled, engineering format. One difference between these, for engineering formats, it's readable values. For 2's complement format, it'll give you hex values, which you need to scale through hex, which makes it more difficult, but you will get better resolution. For this example, I'm just going to use engineering format, and we're going to keep it as is. The AO tab allows you to see the current value of the analog outputs. So currently I have it tied from analog output 0 to analog input 0, which I have set for, in this case, well, it's reading 4.8 volts. And let's see, our DI channels status here. If I had anything wired, I would see the bits here. And the host watchdog is just more of a timeout if you lose communication. Let's see, for this example, let's see, we're good with the default configuration. If anyone has any questions about this, please be sure to ask them at the end. Let's see, I'll move on now. I have to be sure to close this because we can only have one connection to the RS-485 bus at one time, because you can only have one master for Modbus RTU. If you did have Modbus TCP, you would configure that using the web page. Now I will open up Easy Data Logger, drag it over here, and we will create a new project. This is the screen that comes up when you first connect to it. The very first time after you install Easy Data Logger, you want to be sure to run the program as administrator. Otherwise, you'll get an OCX error, and you just need to do that once. After that, you just open normally. But the very first time you open, be sure to right-click and run as administrator after you install it. Okay, so I'm going to create a new project for this. Let's see, I just want to, let's see, I'll name it, let's just call it demo and 2122 for today's date. Okay, it closes. It opened over here again. Let me slide it over. Okay, so the first thing you want to do is click on group setup over here. Let me slide it back over here. Okay, from here you want to add your connection to your device. So you click install. Let's slide it over here again. Sorry about that. And then you want to click Modbus serial because it's Modbus RTU, which is Modbus serial. If you did have Modbus TCP or DCON, you just select the corresponding one and you connect with the property shown. Previously, I showed that was COM port 10. Let me actually bring that screen up since it is in the background. Previous previous. Okay, this is useful. So I'll go back over here. And again, we just want to make everything sort of match. So I'm COM port 10, 9600 baud, 8N1 was my data format. And note I could do Modbus RTU or ASCII, but in this case, it's Modbus RTU. So I click install. It will appear up here. And then I can click plus device here to add my device connection, which of course shows up over here. For this module, let's see, it's an M-7026 module. Let's see, I can just specify the channels, or I can use the drop-down box to select the module if we had a standard configuration. For this example, I'm only going to use a few channels, but you can use the drop-down box and it would just autofill the channels here if you wanted to do all channels. But since I'm going to only do a few channels, I'll just enter them manually and just enable the analog input and analog output registers. Let's just do 2 registers, even though only one's connected, just so you can see the different channels. And we'll just call this M-7026 as a name, and we just click add. It will appear under the device list here, and we just close this window. So we created our connection to the Modbus bus, which is on COM port 10 of my PC. We added the modules. If we did have additional modules, we just add them here, and we can click add if we wanted to add additional ones. This box appears having you select the type. In this case, it's Modbus RTU, but if we did have Modbus TCP devices, we can also add them here. From here, let me expand this a little bit so you can see it better. Okay, so once we add the channels, because I added the 3 channels here, they appear here, and then the analog output channel shown here. I'll go over scaling in a minute, but just want to note that you want to be sure to click on the module you want, or I'm sorry, the channel you want to log data for, and then click add. And then we'll also add these 2, and they appear here on the right side. You could see the channels, and you could also name them later. I'll show you that. But let's just test out and make sure everything's working right. So from here, we click home. And then it appears over here, of course. So we bring it over here, click start. We want to make sure this light over here turns green. If we hover over it, that is our M-7026 module. Let's see, for the virtual channels, and let's see, it's because of an alarm value we have, but okay, we could see our values 4,000 and 4795, basically our analog input channel and analog output channel. Now let's do something for those alarms and get the values scaled properly. So let's stop this. And let me go back to the slideshow. I just want to show you some slides I had. Where we go? Okay, so let's see, for scaling of the analog IO channels, you need to know the full scale range. You could either enter the slope and intercept if you know that, or if you know the value that you want to configure, you can enter them in Easy Data Logger, and it could do it for you. So in this case, 0 volts to 10 volts is 0 to 10,000 as shown here. It's actually going to be negative 10,000 to 10,000. Modbus doesn't have decimal points, so just know that there's 4 zeros and what do you call it for each. So that's why it's 1 followed by 4 zeros for the positive values. And we're just going to scale between 0 to 10 volts in this example, but we can certainly do other values. Let's see, here's a few examples of what I was talking about. So if we, in this case, we're going from 0 to 10 volts, and we just want to do between 0 to 100%. So when 10 volts is applied to the input, you will see 100%. When 0 volts is applied, you will see 0%. If we did the same thing with a 4 to 20 milliamp scale, you would put in 4,000 here because that's corresponding here, and 20,000 here, which corresponds to 20 milliamps. And then you would still scale between 0 to 100. And these would be the resulting values. But our easy data logger will allow you to just put in the values like this. You could calculate, and it will put in the gain and offset instead of having to calculate the Y and the, or I'm sorry, M for the slope and B for the offset. It will do it automatically for you here. Okay, I'll show you an example here in Easy Data Logger. So going back here, I'm going to group setup. Well, what happened? Where'd my window go? Okay, so drag it back over here. Okay, so let me enlarge a little bit. Okay, so for each channel, actually, let me enlarge it. Okay, so for each analog input channel, you can double click on it and it'll bring up the configuration window for this. You could name it a certain name, like call it tank 1, and you'll know the tank value. And then let's see, as I was showing before, you could either do negative 10,000 to 10,000 and do, in this case, it'd be negative 100 to 100. And we click calculate. It gives you a 0.001 multiplier. If we did it the other way, where it was 0 and 0, it's the same thing. If we did know the values ahead of time and we didn't want to go through this, you could just simply type it in here, like maybe 10, and then just click modify to save it. But since we want to just have Easy Data Logger calculate for us, we can do that here. And we just click modify to save it. And we can do the same for the analog output value. Let's do it over here. And let's call it maybe flow. And we just do the same thing, 0, 10,000, and 0 and 100. Or in this case, why don't we just try to do 0 to 10, just so you can see the difference. So instead of 0.01, it's 0.001. And we just click modify to save it. And we come back here, drag it over, click start, and we could view our trend curve here. And we'll see the values. So we see, let's see, the 0 values for these channels which have nothing connected to, that's shown here. This channel is reading 50% because we multiplied by 5, and this one we have it just set for 5 because we did that through scaling. So it's roughly 10 times the difference between those two. Easy Data Logger also has a layout screen, which I'll show you here, where you can create your own pictures and diagrams and move these objects over, use bar graphs instead of and numerical displays to show your channel statuses. Let me actually show you another example. I think we have, need to stop this really quick. Open project. Where's, I think it's this one. Over. And this is our other one with a nicer layout. This demo is one that comes with Easy Data Logger. It just shows basically cars coming from different directions. These are counter registers, but you can see what you want, what you can do. It's just a nice background image, and some labels which show counts, and just make it look like your application a little bit so you can have an idea. Let's see, does anyone have any questions? That's all I have for you today concerning the demo, but if you have any questions, please raise your hand or type in the Q&A box. Let's
We have
see,
a
I see one.
Halcyon Bird is asking, would it be interesting to know how I would acquire a float type of data split over two 16 bits register? How would I merge these two registers and log this type of data?
Oh, okay. Actually, that I could show. Let's see, let me just get this out of here. So let's see, this isn't the project we dealt with, but let's see, as long as it has some analog. Okay, so let's expand this. Okay, so in the step where we add the module or device, let's see, let me go back here. So in this example, it didn't have Modbus RTU, but it has Modbus TCP. So we just added Modbus TCP device. So right here, where we put in the register types, like say it had 2 channels, you just select float here. And there's also float inverse if you had to do a byte swap. So you could do it this way. You just declare the input types as float values. Okay, and it would take 2 registers, whether it be most significant or least significant, and put it into standard float values. So it would display in float values as opposed to integer values. Okay, hope that answered your question. Any other questions? If you would like, we can open the mic if you would like to ask the question live, or if you have any other questions, you're welcome. I guess I answered the question properly because I got to thank you. Does anyone else have any questions? Okay, I don't see any other questions, but again, if you do decide to install our Easy Data Logger, be sure to run as administrator the very first time after installing. Otherwise, you'll get an OCX error, and also be sure to register the product so that you avoid the 2-hour limitation for the demo version. It is free to use with at least one of our data acquisition modules connected. And if you have third-party devices, you can connect those thereafter, or you could buy the advanced or professional license. Does anyone else have any last-minute questions?
Or if you have any questions in the future, you can always reach out to us by phone or email. We'd be happy to help you.
Okay, I guess no other questions, but if anyone does have any applications they'd like to discuss or would like to go over more details or have questions, please feel free to contact us. We're here to help. Thank you.